Okay, so you're gonna let f of x be the basic reciprocal function. And I'm happy, well, we already posed this, but f of x is a basic reciprocal function. I gotta say that I'm not getting any video because I got the lens cap on. Oh, well, I could start this one over, but I don't mind a little humor at my own expense. I just pressed the wrong button here, but I don't think anything happened, so. Oh, wrong. I'm off to a good start here. Okay, let's come up here. Let's zoom in a little more. Let's come down a tad. And it still won't. Okay, there, now I can zoom in a little more. Go the wrong way. Okay, I don't know what's going to happen here if I can't operate the remote properly. I don't know what I'm going to end up saying, but here we go. Keep an eye on me today. Okay, if f of x is a basic reciprocal function, okay, we want to find each of these expressions. I don't have to read them to you. Everybody did this pretty well, okay? Because pretty much everybody identified the basic reciprocal function. Now, you want f of 3/4 equals what, okay? But you know, we don't want to write that first. First thing we want to write, you know, a lot of people, I mean, in other words, started out by writing f of 3/4 equals because they know what the basic reciprocal function is. And for the most part, they did that correctly, okay? But you really want to write out what your function is, okay? You want to declare the function partly to communicate to whoever might be reading, because you want to learn to be able to communicate things, okay? And if you can communicate mathematics, you can communicate pretty much anything. So it's a communication thing that's kind of peripheral to the mathematics course, but in other ways, it's really simple, okay? So you have f of x equals 1/x. So that f of 3/4 equals 1/3/4. Now, a lot of times when you plug in, you've got simplification to do, and certainly you do here. That's not a simple fraction. Well, it's 1 divided by 3/4, which is 1 times 4/3, and that's pretty easy, okay? But, you know, we want to make sure we understand that rule, so we want to write out the simplification. We're not going to do that yet. We're just going to do the substitution. So we have the meaning of the function notation, then we get into the algebra and the arithmetic, okay? So what's f of -3/2? Well, that's 1/3/, right? What's f of a? And I think everybody wrote this out correctly. Means you paid attention last time, maybe, or you watched the video, or you learned something accidentally or on purpose, whatever it takes, okay? Okay, so that's good. I got a good response there. Now, this one I know is going to confuse people. I knew it when I wrote it down, and I'm not surprised that everybody was a little confused, although a lot of people wrote out the right answer, they wrote it for the wrong reason, okay? So f of a over f of b equals what? This is not necessarily f of a over b. I'll give you an example in a minute where it isn't. In this case, it is, but you can't assume that it is. You got to do the substitution, and you got to do it one step at a time. And one step at a time is that f of a is 1/a, and f of b is 1/b. So f of a is replaced by 1/a, f of b is replaced by 1/b, and you got your fraction bar there, right? You want to be as literal as you can when you substitute in here. You can't make assumptions. And you're making an assumption if you think this is the same as f of a over b, okay? It is, but that's not always the case. Okay, so f of a over f of b is this. Now, and of course, And this one kind of goes along with this picture. Okay, so write f of x plus delta x over here. I'm going to say that one over x plus delta x. And everybody wrote that down. You didn't necessarily relate it to the picture, but I didn't really ask you to. And of course, this isn't the picture of your basic reciprocal function. This is a picture of any function. So if x is here and delta x is this far, then this is x plus delta x, okay? And f of x plus delta x is what you get when you come up to the graph here and project over. So just to give you a little extra information here, right there is f of x plus delta x. And f of x is this. Okay, so there's f of x plus delta x, there's f of x. Now, if you understand that much about the graph, then you're beginning to understand things about this expression, which is really crucial. You need it for pre-calculus early in the course. You need to understand its meaning as a rate of, as how it is involved with the rate of change. And you see that like in the second week of a pre-calculus course. Okay, so you kind of want to think about this picture, because what we're doing right now is I'm giving you a little bit of the pre-calculus course. Some of the things that will trip you up and hang you up, okay? So that you don't get tripped up when you get in there. Okay, well, anyhow, or so you're at least less likely to get tripped up. Some things are just tripping. You know, they trip everybody up. Okay, so anyhow, there you have that. Now that's a lot more detail than what I asked, which was just what's the expression, and everybody got the expression. Okay, just pointing out has a bigger meaning. Okay, well, let's do some arithmetic now. What's 1 over 3/4? Now I really want you to write this out to reinforce the rules. Okay, don't just write out the answer, write out the rules, because the rules are going to apply when you have more complicated expressions. And if you just do it by the way it looks and by habit without applying the rules, you're less likely to understand the application of the rules when it gets complicated. This is uncomplicated. You pretty much know that that's the reciprocal, so you're going to get 4/3. And you should know that, but write out why. Okay, because a fraction means 1 over 3/4 means 1 divided by 3/4. Division by fractions, multiplication by the reciprocal. Of course, that equals just 4/3. Okay. So go ahead, if you haven't completed it, and write out the details for the rest of these. Of course, there's nothing more to write here because you don't know what A is, right? But there's more to write here and more to write here. See if you can write out in terms of the most basic rules, what you get here and what you get here. Okay, I think everybody's in pretty good shape here. This is what you should have written. If you didn't write it, make sure you spend some time making yourself clear on it. This is 1 divided by -3/2 is 1 divided by -3/2. Okay. Don't need this mask up here. Maybe I do. Just a quick COVID story. Good friend of mine from college. Okay. My girlfriend and I set him up with his lifelong wife. Okay. And see him every few years. Well, he's traveling by, he's going up the Blue Ridge Parkway, he's gonna come over today or tomorrow, okay? And we talked Monday, and he was about to eat dinner, but it determined that, you know, this afternoon would be a good time. He said he'd call me back after dinner. He called me back after dinner and said, I got COVID. So needless to say, he wasn't in bad shape with it. You know, he said he got a little stuffy and, you know, a little tired, but nothing unusual. Of course, at our age, you worry about long-term effects more than you worry about COVID itself. So, you know, my main concerns with him, but I'm also glad we dodged the bullet. Because if he hadn't tested, he got a call from his sister-in-law. They'd all been down to Disney World with all the families came together. And sister-in-law is a pediatric nurse. She said, I got tested positive, you know, better test herself. So between the two calls, just a few hours apart, he tested himself and realized he was positive. So as I say, I'm going to continue to wear the mask when I'm back there talking to you guys. Not that it's going to protect me much. It's likely to protect you a little more, okay? Because I'm the one that's usually doing the talking when I'm back there. You guys just stop breathing when I come around, all right? I won't stay too long, I promise. Okay, so we're just being, you know, just taking precautions that are probably not necessary, but cases are rising again, so we do want to take some precautions. Okay, so anyhow, 1 divided by -3/2, which is 1 times -2/3. And 1 times -2/3 is I don't -2/3, 1 times anything. Now you put that negative anywhere. I put it in front of the 2, but it actually could go out in front of the whole fraction. Means the same thing. Okay. Now this one down here is 1 over A multiplied by B over 1. Well, and I skipped a step there, like I tell you not to. It's 1 over A divided by one over B, and now that's 1 over A times B over 1, which is 1 times B over A times 1. And of course, 1 times B is just B, and A times 1 is just A. You really want to write out all those steps until you're really, really used to all those steps. And then maybe you write out all those steps one time out of 4 until you run into more complicated expressions where you really need to write out all the steps, okay? You got to know what all the steps are so you can write them out when you need them. Keep stressing that. And it's a little hard to make yourself do that when you know perfectly well how it's going to work out, okay? That you're reinforcing the steps you're going to need when you aren't clear on how it's going to work out. Okay, now let me give you an example of why f of A over f of B is not equal to f of A over B, okay? Because I'll make the observation. Okay, so f of A over B is f of A over B for this function. And it's also so for most of the basic functions because they're very simple. Okay. And in pre-calculus, you build functions from the basic functions. Okay. I'll probably give you some examples of how that works. I'm going to say it's not so even for the basic exponential function. Now, as it turns out, most of the basic functions are power functions. Okay. Most. And it's always, this would always be so for power functions. For any other kind of function, it's probably not so, almost never so. Okay, and it's not so for the basic exponential function. So the basic exponential function, find the expression for f of a over f of b. I'll start by writing out the basic exponential function. F of x equals what? Okay. Now, most people have the correct expression here, but not everybody did because some people wanted to say it was f of a over b, and what we're showing is that it's not so. Okay? This is not going to work. Okay? So if you write this out carefully, A is 2 to the A. F of B is 2 to the B. So you cannot argue with the fact that f of A over f of B is 2 to the A divided by 2 to the B. Okay. Now, at this point, nobody so far has gone past this to simplify it. Okay, did you get it? Okay, hang on. We've got a success here, but let's. Okay, I believe we got the camera focused. Okay, your rules of exponents. Let's write it out in terms of x's and y's. X to the A times x to the B equals x to the A plus B. This is because x to the A means a bunch of x's multiplied together, right? Multiply them together A times, and you multiply them together B times. And when you do, you're going to have A plus B of it. Okay. If you got 2 of them here and 3 of them here, you're going to have 5 of them total. Okay. So even simpler. X squared times x cubed is x times x multiplied by x times x times x, which is x to the fifth, right? Because now you got 5 of them. Okay. This is the reason, and you really need to start by understanding this and then seeing how that leads to this, which then gives you the rule. Okay. So this is x to the a, this is x to the b, and this is x to the a plus b. Another rule. X to the negative a equals 1 over x to the a. Okay. This had better be true. Since x to the a times x to the negative a equals x to the a plus negative a, just using this rule, if we add the exponents, which is x to the 0, which is 1, right? Since x to the a times x to the negative a is 1, if you solve this for x to the negative a, divide both sides by x to the a, this is what you get. Hence the rule, okay? Therefore, the rule. It can't be otherwise if we're going to have a consistent arithmetic or algebra, okay? And then x to the a divided by x to the b is x to the a minus b. This is since x to the a over x to the b is the same as x to the a over 1 times 1 over x to the b, which is x to the a times x to the negative b so we add the exponents a and negative b, and that's x to the a minus b. Okay? So those are your rules. Now, knowing these rules, we come back over here and simplify this very easily. So this equals 2 to the a minus b. Okay? Now let's make sure we understand the lesson of this rule. I f of a over b. Okay. Since f of a over b would equal 2 to the A over B. Okay. So this is different than this. And A over B, A minus B. Now, I've lapsed into formal mathematical language with the ain't, because that's how you say things in formal mathematical circles, okay? It ain't so. Well, we don't really say that, but we ought to. We just say, and therefore we have a contradiction. Well, other people, I say, it ain't so. All right. That makes sense? Okay. This function, we want to do f of A over f of B. You're really best off not making any assumptions. Write out what f of A is, write out what f of B is, then put the f of A over the f of B. So f of A is A squared plus 1. That's pretty clear from the definition of the function. Now, some people wanted to pull out the reciprocal function that we dealt with earlier, but that's not part of this definition. We could have done a 1 over x squared, be a reciprocal square, or 1 over x in here, and we would have had similar results. This will not equal this, okay? As I said before, this is equal to this only in very few cases where you have just a pure power function, okay? And I think you can prove that if this is always equal to this for a function, then it is just a pure power function, x to some power. Okay, well, anyhow, f of A equals A squared plus 1. F of B equals B squared plus 1. So that f of A over f of B is A squared plus 1 over B squared plus 1. Now, on the other hand, so here what we've done is we've done f of A over f of B. With our sequence of reasons, right? Now, on the other hand, f of A over B is replacing x by A over B. So you're going to have A over B squared plus, okay? Now, this doesn't look anything like this, okay? Although you can kind of see like an A squared over B squared here, it's not going to work because you can't factor it out. So this should be really clear on how this isn't, and also to review a little of the algebra you need to know. This is A squared over B squared plus 1, right? That's two fractions. You can add them by using a common denominator. You can write 1 as just B squared over B squared, just another way to write 1, right? And then you can add the fractions by adding the numerators. And there's no way this is equal to this. Okay? Unless you somehow think you can cancel this with this to keep this under the A squared. Okay? And even that, it's not going to work. F of A over F of B, which is this. Which is not equal to F of A over B, which could be written in any of these forms. You can easily prove that they're not equal. Okay.